Hi, it's Tim. Welcome to the channel. Today we have on the bench a bunch of bits and we are going to be building one of these. And this is, or at least it's going to be, a 1581 disk drive. So let's do it. So this is all the bits to build a 1581, at least I hope it's all the bits. We've got a stack of components, we've got a 3D printed case, which I printed a while ago on my 3D printer. We've got a drive, and of course the boards. Now these boards came from PCB. You saw we unboxed them on an earlier video. These boards are actually the interface to go from the main PCB to the actual drive itself, because we've got one of these PC style connectors. So let's open up the circuit boards and see what we've actually got. These of course are a shared project on PCBWay, and you can order them simply by going to the page and then just basically you select what color you want. Order the boards and in a week or so they will arrive. There we go, let's pull one out. I got these in white. You can of course get them in any color you like. So that's the top side, that's the bottom side. Let's look at this other board. This is the interface, and again I got this in white. Basically it takes a 74HCT02 and there's a connector that goes, I think, to here, and then another connector that goes to the drive. So basically it just maps what you've got to what you expect. Let's sort out some components and start to build this. We're going to start with the low components first. So that's going to be resistors and diodes and so forth. I have got a bill of materials and we'll just work our way down. Okay, let's find some components. Right, we've got our parts here in this box. We've got our PCB. We've got our bill of materials. And I think everything on here is in these two boxes. So obviously there are more of the components than there are actually components to put on. But we will work our way down. We'll start with the smallest components, and that's going to be the diodes. Here we are. There we go. So the diode is 1N4148. This is a 1N4148 CR4. CR4 is here. Not particularly straight. Right. So, bar goes to this end, bar goes to this end. There we are. Spin that in. There we go, we're soldering it from the top. Why? Why not? It still produces a neat outcome. Okay, so resistors 47 ohms. Right, we've definitely got some 47 ohms. 47 ohms, right. I should have my support brackety thing, but it's gone missing, so we are without. 1, 3, 9, 10, 11. 10. These are dictating which way round they're all going to go. Although it doesn't matter for neatness, it's nice if they are all the same way round. Right, what I'm going to do is tack one side of each capacitor and then I can turn the board over. It's a good idea to keep your finger over the end of the wires just so that they don't fly off. Okay, we'll get the IC sockets. Okay, sockets. I shouldn't have put that on. I'm going to fold him down. So, that's a 20. I'm just going to tack one corner down, or possibly two corners. Okay, we're getting there. We just have the extra power supply stuff, the connectors, and the switches. Oh, and the crystal, of course. So let's put the crystal in. 16 megahertz. Now, what pin is what? That must be pin 1 because that is the sharp end. But, and let's go and look this up because I don't want to get it wrong. So I've checked and pin 1, which is the square angle, is not connected. So that goes to there. Then opposite there is plus volts, ground and out. So pin 1 goes to that one. Like that. Okay, so we just have these connectors, the power supply regulator, jumpers, and these to do, and we are getting there. I'm not sure whether I'm going to use the external power supply. I don't have the proper power supply to use the power input for this. So I'm going to build the power supply section. It can be jumpered out, I believe, in any case. So C24, 4.750 volts. And I'm going to fit that laying down to start with. That, I believe, is the jumper that determines whether... Oh, you twit. That's the voltage regulator. Just undo this mistake. So we might as well fit the regulator next. That's going to go here, and we are going to put that like that. So what we need to do, basically bend the pins, and we fit a nut and bolt onto this like that. There we go, that's the voltage regulator. And C23, positive, this is negative. Okay, let's put the device number selector switch on. This is power to the drive, and we will put on the switch. That is the main power switch. There we go, the 4-pin one is the power. I'll just tack the corners of these until they are in. Now these are for if you have a dual 1581D drive where you've actually got 2 discs, and I think you need 2 boards. We're not making one of those, at least not today. So that completes the soldering, except possibly for this jumper JP2. That is dependent on one of the chips that we are putting in. This is a draw off of the IEC cable. You can use it, I believe, for the internal connection to the 1581D second drive, or if you have some other reason to take off a tap for the IEC cable, then you can do it. So maybe you want to monitor the signals, I don't know, whatever. That, I believe, is the device number for the second drive. Before we go any further, we ought to do a quick voltage test, or rather a short circuit test, between the supply rails. Set that to beep. We can go between these decoupling capacitors. That will just tell us if we've shorted out the voltage rails. Nope, no short. That is good. So now we'll start putting in the ICs. Let's put my strap on. So the first one is going to be the 6502. This is W65CO2. And that goes in here this way up. Thing is in the top. Everything else pretty much goes that way, but this one goes this way. There we go, make sure he is in. And for a W65CO2, according to the bill of materials, J1 is open and J3 is closed. J1 is open and J3 is closed. Let us stick a thing on J3. Our other big chip is the 8520, which I have in here. This is CIA 8520 4391. Okay. And this goes this way around. Next chip we have in this tube is the WD1770, which is the disk controller chip. And that goes in here. Like that. The final big chip is our 27256. Whoops, actually 27C256, and this is our ROM, which is 318045. This is the standard second iteration 1581 ROM, and that goes in here. We have an 8K of static RAM which goes in here, but they have not arrived yet, so we're still waiting on those. And the little chips, so this chip is going to be a 241. Now we can put a 27512 in here, and we can have a choice of two ROM images, so we could have Jiffy DOS and the regular thing, and that would be switchable, in which case that's actually switchable from here. So because this is a 1770 and not a 1772, we need J1 closed. J1 is this. So that's interesting because, no, JP1, okay, so that's down here. So JP1 opened and JP3, where is JP3? Okay, so we have to close that with a blob of solder. There we go, that's blobbed the solder. So JP2 is going to be according to which static RAM that we have in here. We've not determined that until it arrives. I've ordered both kinds. That is going to be a case of which arrives first. So the big one here, 74LS241. That's a 93, and that's a 139. The 93 is U10. And it's the 139. This can only go in one place, and that is here. These others, U6 is the 139, yeah. U7 is the 00. Has a bent leg. Pin 1, pin 1. And it helps if I put it in the right hole. U7. 00, U7, yes. 8 and 12 are the 6s. Correct way round. Correct way round. 7 is U11. That's the 14. Is U9. And the 93 is going to be U10, and that is up here. There we go, we are just waiting on that one SRAM, and then we are done. Now the final chip has arrived. This is a D4364C. We had a choice of two chips. Basically I ordered both, and the one that arrived first is the one that I'm going to use. So I shall put the wristband on, and we can just fit this. 8K SRAM. So double check that's pin 1, that's pin 1. And there we go. Now there is a jumper, JP2, and that is set according to which of these chips that we have in, and according to the BOM sheet, JP2 is closed if we have the AS6 and it is open if we have the D436. So we leave it open because we have the D436. As far as the power supply is concerned, I do plan to build a proper unit. If you remember, we had a Meanwell left over from when we built the +4 power supply, so I'm going to use that. But for now, we're going to use the built-in one, which is special to this board, and that is powered through here. I've built a cable to take a simple wall wart. Here we go. This is 12 volts, 1.5 amps, center positive. And so I've wired this up with a barrel jack socket and the appropriate plug for this, and positive there, and that is actually center positive. So we can plug that in. And I've also wired up a little LED board, 2 LEDs. This is eventually going to go in the front panel. I don't actually have any of the small rectangular LEDs. Here we go. Whoops. Front panel. This is the eject button. I don't have the little square LEDs for that, so this is going to do for the moment. I have to decide whether to keep this front bezel on or whether to take this off and fit it onto here. If I keep the bezel on, I need to print a different front panel that has a cutout. I can do that, it's not a problem. So I don't know which is red and which is green in terms of this. The red wire is the red LED. Basically negative, negative, and the positive of both LEDs is back down the middle. That goes to 5 volts. So that can go in here. I'm not going to wire up a C64 or a disk drive at the moment. I just want to see if it powers on and if it basically works. So let's do our sanity check for shorts. So set it to ohms. Let's have it beep. And once again, I'll just go across one of these decoupling capacitors. $141 ohms, that's okay, yeah. It's not a short. This I think is down for off, which of course is the American style. So the wall wart has power. This jumper here sets whether we are using this section or this section, and it's directional. So if it's jumper is that side, then we're using this. If it's that side, then we're using this. Obviously we can only use one power supply at a time. Right, the moment of truth. 3, 2, 1. Well, that's positive. So we know the front one is green and the back one is red. Green is power. I don't think it really matters which way round they are. I've seen drives that have both green as power and red as power, and green is status and red is status. Now that is interesting. It is fading. Why did that fade? Let's just check some voltages, shall we? So V in is 12 volts. That's interesting, we are decaying. To coin a phrase, well, there's your problem. This chappie is in backwards. This is U11, which is a 7407. The other thing that was wrong, and I replaced this off camera, but these resistors here are all supposed to be 47 ohms, and currently they are 47 ohms, but I had them, for some reason I'd managed to put in 10k ohms. So, and because this is the clock generation circuit, that was never going to work, but they now have the correct values in them, so let's give it a try. Right, power on the power supply. Oh, I also changed this because this gets rather hot. So instead of using 12 volts, I've changed this to a 9 volt brick. And the only 9 volt brick I've got is center negative, so I've had to swap these around. Which is why this is a yellow one, to remind me that it's not the regular black. Ultimately, I'm going to make a power supply for it, but we don't have one yet. I'm going to put that there, just so that it doesn't move. Right. Let's power it on. Okay, 3, 2, 1. That should have done something different. Let's power it on. I think maybe this wire was not plugged in. That's a downside of the DuPonts. 3, 2, 1. There we go. That's powering up, and the correct sequence is the power light comes on, the drive light comes on, and then after a second or so it goes out. So, yay! The next thing is going to be to try it with the floppy itself attached. And to do that, I think I'm going to put it in its case, because there is a caddy that holds this apart from, because it sits on top. And so there we go, I have a 3D printed caddy, which basically this sits on like that, I think. And it sits above the board in the case. So let's assemble this and then put that on and see if it still goes. Unfortunately, this drive should have a top to it. It does look like it's been wired up to be an Amiga drive. You can see the little bodge wires in there. That means we shouldn't need the add-on board for it, but we will see what happens. Let's do that. Let's plug it together. So we've got this in here. I guess it's because it's a fairly short cable. This in here, we're not going to worry too much about everything lining up, because when you screw it down, that will be fine. These have come out again. I might take this off and just replace it with DuPont style headers. Okay, the power cable is plugged in. The power cable to the drive, that is. This is the power cable to the power supply. And this is my drive light. Now, obviously, these round LEDs are not going to fit into this. And I would have to take that off. I've printed out a button for it. It's not quite the same shade of cream, because I ran out of this stuff. Right. Get in, stay in. That's an aircraft evacuation manta. Get in, stay in. Actually, get down, stay down is the correct aircraft one. So now comes the moment of truth. Just turn it off at the switch there. Turn it on at the mains. I have no idea if this drive even works. So oh, I heard it move. And of course the red LED is not working because that switch, but let's There we go, and I felt that drive move, so that's encouraging. But I've noticed that this light is on. I'm not sure if that's a function of the cable, whether it means I need the other thing. I have actually got, it's a very Heath Robinson, but I have built up the other board, which is an adapter. Well, so I've built it up, I haven't got that connector on it yet. So if we need to adapt this, we can actually use this board. But what to do next is plug this into a computer. So let's go away and set up a computer, and I think it's going to be the 128 because this is a 1581 and it should work in fast mode. Let's try it. Okay, it's the +4 rather than the 128, but it still has the basic 4 disk commands, and so that is going to make life easier when it comes to testing this drive, because we can just type $DS$ instead of all the faff with open 15,8,15 input #15, etc, etc when we want to read the error channel. Okay, so let's switch it on. There we go, and let's power up the disk drive. Switch it on at the wall. Red light comes on, red light goes out, green light stays on. That is what we want to see. Right, so let us interrogate the drive and see what it is doing. This will determine if we can actually talk to the unit. And to do that, it's simply $DS$. And look at that, 73 copyright CBM DOS V10 1581. So we know we can talk to the drive. There's no disk in the drive. Let us try. I'll abbreviate these in future, but I'm going to type them out in full to start with. Nothing happened. The green light is flashing. I think these are probably the wrong way around. I suspect probably red is supposed to be status and green is supposed to be activity, but it's just a matter of reversing those connections, so I'm not going to worry about that for now. Right, once again, 74 drive not ready. Well, we kind of expect that because there's no disk in it. So I've got a couple of disks. These are double-sided, double density. I have tested them in an Amiga and they work fine in the Amiga. They are currently Amiga formatted discs. I do not have any actual 1581 formatted discs at this time, so I'm not going to expect very much initially from sticking the disc in the drive, and pretty much nothing happens. But if I turn this over, you can see the drive is spinning, so it has recognized the disc. So let's see if I can remember the basic format command. Are you sure? Yes. Something's happening. I can hear it going round. The light has gone out though. Ah, bad disk error. Drive not ready. Just take it out and put it back in. Try again. Are you sure? Yes. Bad disk error. Drive not ready. Now the error light was not coming on, which is interesting. Let me be cheeky and try it with the right protect tab on. See if it recognises that. Yes. Hello, everything's gone out. Dodgy connection, it's fine. Drive not ready. So it's not recognizing the fact that the Write Protect tab is on. Let's try the other disk. Now these are both formatted on an Amiga within the last hour, so I definitely know that they work. Are you sure? Yes. And nothing's happened. Again, 74 drive not ready. Okay, the batteries ran out in the sound recorder. I do apologise, and then they ran out in the camera. So what I think I will do is try swapping around this cable just in case it's actually in backwards. I don't think it is, but we will try. This is not a keyed connector, so it's possible that the silk screen is not labelled correctly, or the cable is not wired correctly. So we will see. Right. Power on the computer. Power on the disk drive. Try and get those lights looking towards the camera at least. Stick a disk in. Well, that's not a surprise. That came on, went out. Bad disk error, exactly as before. Drive not ready. So, turning the cable round made no difference. Nothing says it's a few days later quite like moving your camera to the other side of the desk. I've been talking to the guys on the YouTube Retro Repairers group, and off camera we have tried a bunch of things. So let's take this off. Interestingly, 3 of the guys there have also built 1581s. Some have used this board from PCBWay, others have used a different board, and some have used both. And all of them are having the same problem. And the problem is that anything that you do with a disk drive comes up with a drive not ready error. So over the past few days we've tried a few things. Originally in here I had a W65C02, and this jumper was set and this jumper was clear, and we found some mention online that said the W65 can't handle the TTL levels, and so you need to change it for a straight 6502A. And so this is a 6502A. That jumper is now clear and that jumper is now set. It made no difference. We've also tried swapping the WD1770 for a WD1772. That made no difference. When you do that, you need to remove, I think, this jumper. Now I'm powering it through the aux connection, which is this little thing which is only on the enhanced board. And the thing with this is that it only provides 5 volts power. It does not provide 12 volts if you power it through this jack. And the reason I'm not powering it through this jack is that I need to build a power supply to do that. Now I haven't done it at the moment. But if it's powered through that jack, you get 12 volts as well as 5 volts. Now this drive only uses 5 volts, and this is a SFD 321B, even though it's not got its top on. If you take this plate off, it actually says it on the board. Now this drive has been modified to run on an Amiga. I have not currently plugged it into an Amiga and tested it. That is something that I need to do, so that we can say that the drive itself is not faulty. What is interesting though is that Lee at Captain Commodore has built one of these using a Gotek. He said the floppy drive itself would not work, but if you put a Gotek in there, then it did. And I'll link to his video for that. So what I'm going to do now, against the advice of the other guys, because they say they've tried it and it makes no difference, is I'm going to try a different floppy drive. Now this one, again, it is SFD321B, which is made by Samsung. This is compact labeled. So originally it came out of a compact. It is a PC drive, so it has not been strapped up to work on an Amiga, which means that to use it, we are going to need to use this board here. And this also came from PCBWay. I'll put a link in the description for the particular project for this. And it is basically an adapter with a little IC in the way to basically talk between this and a PC drive. So what we do is we plug this into here like that, and then we plug this into here and this into here. Interestingly, this does swap the drive cable around, so it is going to be straight through. Right, so we've got this. This drive doesn't have a front bezel because it came out of a laptop, I think. Power up the +4 and power up the drive. It's interesting, the activity light on the drive itself is still on as it was on the other one. Okay, I apologise for the extreme angle, but let us once again just do a quick okay, so we'll try with a disc in there. Directory should give us the error still, because this is hello. There we go. Because this is an unformatted disk as far as the 1581 is concerned. 74 drive we're not ready. That is not a surprise. So I'm going to go to the open 1.8.15. Simply because this seems to give better results in terms of generating an error in 081. Oh, can you hear that? Something is happening. And it seems to have done it. (1581) TC 3D 3160 blocks free. I kind of wasn't expecting that. Yeah, it works. Now I could have ended the video there on a positive note, but that would not have been honest, because it stopped working. It worked fine for a little while. I was able to format 2 floppies with it, but even so it has a problem in that it does not recognize a disk change. And then, well, it stopped working and it went back to going 74 drive not ready. So over the last week I have tried loads of things. I have tried 65C02, I have tried 6502A, and I have tried a 6502 straight. This has currently got a 6502A in it. I have tried WD1770 and a WD1772. I have tried the 6526 out of a Commodore 64, as well as the 8520, sorry. I have tried several 8520s. I've raided my Amiga 500, tried both of the CIAs out of that. I've tried different ROMs, I've tried different RAMs. I have replaced every one of the RAM chips. The HC02, which I originally put in there, has been replaced by an HCT02 because they finally arrived. None of that makes any difference. I have even built a second board using a completely different PCB. This is by DIY Chris, and in fact this is the board that I originally bought I guess nearly 2 years ago, and I finally built it up, and I've used discrete resistors here instead of the resistor packs there. And again, I've gone through all the permutations of ICs, and this behaves exactly the same. It just gives you a 74 drive not ready every time you try and access the disk. I have also tried, this is, oh, leads come off. This is a PC drive. It is a SFD321B. That is a fresh buy. This is also a PC drive. Again, it's a SFD321B. That uses the little daughter board. This is the original drive that we were using, and it is an Amiga drive. You remember it hasn't got a bottom plate. And this is another Amiga drive. It has come out of my Amiga 500. It is a known working drive. So in fact these are all known working drives, but the 1581 does not want to know. And all the ICs work fine in their own respective systems. So what I'll do is I'll just power this back up again and show you what it is doing. Okay, I apologise for the angle of the display, but there you go. So turn him on. You can see the drive light comes on. No disk in the drive. Directory. Flashing light. Drive not ready. Now we expect that because there's no disk in there. That is fine. This is the 1581 demo utilities disk. It's a fresh purchase. I'm not convinced that it's 100% reliable because I think there's a directory error on it, but it should work. Now there's no noise. It's not going to work, is it? Because that's still unplugged. You idiot. I've also tried several different cables. That's the CD32 power supply. This of course is my +4 power supply, which is 3D printed. We did that the other week. Right, okay, let's have another go. There we go, we heard the drive that time. But still we are going to get, let's just do, that should give us our ID, oh no it doesn't. That should have given us our ID string. Let's just hit reset. No, it's not talking. Ah, there it is, it's come up now. So now we'll put the disk in the drive and hopefully, no, see, disk is in the drive. And we are still getting the drive not ready. If we look at the underside, we can see that the disk is actually spinning. Take that out, try a different disk. This is the one that we actually did manage to format. Directory again. But the problem, The problem that I've been having with this is, even if it works, it does not recognize a disk change. So sometimes if we do this, send it an initialize command, the initialize command is basically supposed to reset the disk in terms of reading it and reloading the directory and so on. That might clear it. And yes, it has. So you see that we've come up, and this is called gash disk, and you can see 3159 blocks free. There is nothing on it. Now, if I go to the 1581 utilities disk, we're lucky that this is actually working, because quite often it has not been working. But we do directory again, and it still says gash disk. So we send it the I command again. It did nothing. You can see it accesses the LED at least. But we'll go down here, directory gash disk. If we turn it off and turn it back on again, that has actually read the directory from this disk. You see there are these odd bits in the directory which are 0 bytes and splat files. They call those splat files. That indicates that it's a problem with the directory that has got gash in it. Okay, so exactly the same. This one has got the original drive on it, which is our topless Amiga drive. This is once again tested in an Amiga, known to work in an Amiga, and this is my original testing mark on it, tested 11th of March 2022. That can just rest on the tray. That's mostly to keep the flywheel from touching anything. There we go, it's the same LEDs from the other drive. So the drive is resting on the tray, which is basically there to stop it from shorting out and contacting LEDs as before. Power it on, you see it's behaving quite properly at this point. Let us go to the screen. We will put in this disc, simply because we haven't used that before. That gives us our copyright message, which is correct. I burnt the same ROM in this as I did in the other one. Now, because this is an Amiga drive, it plugs straight into the board rather than going through the little daughter board. But the effect is the same. Try a different disk. Drive not ready. Do our eye test. Accesses the drive, but this time we still have drive not ready. So, and again, this unit has worked, but exactly the same as the other one. Most of the time it will give you drive not ready. We can turn this off for a second. We can put the same drive in that we saw from the other machine. Let me just plug that in. And here we go. So we'll use this disk. You're hearing it move the jobby about. We don't actually have the +4 switched on. Let's switch on the +4. That should reset the drive. And that is working. Now that is interesting. This behaves differently every time I run these tests, and that detected the new disk being put in. Let's take the third disk from the other machine. Now you notice there's actually an awful lot more stuff on there that we didn't see before. So with the other unit and this drive, we only got some of the directory. I hadn't noticed that before. And this is now effectively working completely properly, because it's detecting a new disk this is the same drive. Yeah. Oh, have I spoken too soon? Yeah, I've spoken too soon. You see, now it is not detecting a change of disk. It did before. $27 read error. That's because I was, presumably because I had the disk out. 74 should have been $. 74, of course, is drive not ready. Go back up here and do the I thing. Light comes on, drive. You hear the head move, and the drive has now stopped spinning, in fact. Yeah. So on this one, the drive stops spinning once it's done it. On this one, the drive keeps spinning. Now, all the chips from that have gone into here, and all the chips from here have gone into here. So, I don't know what's going on. This, of course, is our classic 10 print program. We've all seen that. And that once again is reading our new disk. So what to do? You can see my problem. I can't really call this done because it's unreliable. Sometimes it will work, sometimes it won't work, and I really don't know why. I have a thought, and as I said, I've changed all the chips, I've changed the cables. You see, I've got spare cables. I've changed the drives. All the drives are known to work. What I could do is recap these drives. Maybe, I don't know, maybe the capacitors are marginal enough to not work in this, but they do work in, for example, the Amiga or the PC. Maybe this is more sensitive. Maybe this is more fussy, more particular. I'm kind of clutching at straws, but it's something to try. If you happen to know what the problem is, please, please, please tell me in the comments below, because this is frustrating beyond belief. Retrobits on his channel built one of these 2 years ago, I think. I'm not sure which board it was. It may not have been either of these, but his worked perfectly first time. So I've been in touch with him, and he said to me, yeah, it worked perfectly. It's worked perfectly all the time since then. And then I asked him to try something, and he said, funny you should say that. Today it has stopped working and returned 74 drive not ready. So either I've jinxed it or there is something endemic. And he said that he looked at the capacitors on his drive, and his drive is also an SFD 321B. And he changed the capacitors on there, and the ESRs were well out. So I think it might be worth having a go. Now I've taken one of the PC drives apart and you can see immediately how dirty it is on the inside. And there are two there, and they're electrolytic capacitors, and these are 47 microfarads 25 volts and 47 microfarads 25 volts. So I think we can change those because we don't know what state they are in, and this drive needs cleaning, so I'm going to clean that as well. Can't really tell how dirty the head is, but we will clean that. And then the worm drive looks like it needs greasing as well, or at least cleaning and greasing, so we can do that. And then we'll see how well it performs. And if it works for this one, then I'll do the others as well. Let's just look in my bumper box of capacitors and see if we actually have the right ones. Ah, right on the top. 47 microfarads, 25 volts. 3 of them. That's one more than we need. Okay. Now I'm not taking the entire mechanism apart, but I've taken the top plate off, and you can see just how much dirt there was in it. And in fact that is just from the head itself. I didn't use that on anything else, that's just the head. So I've cleaned the worm drive with some IPA, so that will just need some grease on it now. Okay, so here I have my pot of magic grease, Mollycott. I'm just going to take a small amount of that. And grease the worm drive. That will sort itself out when it starts working, and then I'll put some grease under here when I've put the lid back on. Now these came out surprisingly easily, so I've got my meter. Let's just test them and see what values that they come up with. Okay, press the button and it will do the test. It's a very rough and ready tester, so we shall see. ESR is 2.1 ohms, 1.4% VLOS, 49.78 microfarads. Okay, and it's nominally 47. Let's try the other one. 2.1 ohms, remember that. Okay, let's try the other one. 45.6, 2.1 ohms again, and 2.1%. So let's try one of these new ones. Okay, do the test. ESR 1.7 ohms, VLOS 0.8%. So the VLOS is definitely better. 46.13 microfarads. So these are better, but they are not orders of magnitude better. But we can put these in. Now, negative was going that way, so negative, negative, and it's marked on the board. Double check, it's actually marked positive on there as well. Okay, and that's negative. So let's also put this one in. Positive is this side, negative is towards the wall. Solder these in. Okay, do we want to take bets on whether this is going to actually improve anything? So it's back together. Drive, adapter board, power, serial bus, +4, screen, which you can't see at the moment. Actually, we don't have the LEDs plugged in. +4 on. Good. That's a good start. I heard that actually move. Just verify we've got communication, and I'm going to start by sticking in the test demo disc. Let's just look, see if it's spinning. Yes, it is. And that's a no. 74 drive not ready. So, recapping the board did not help. I've got to say I'm kind of at a loss at this point. We know the drives themselves are fine, and in fact the capacitor values, while they were a little bit off, they weren't dramatically off. The computer electronics works. I think it has to be something in the interface between the drive and 1581, but I don't know what, and I don't know why. If you've come across this, then please drop a comment in the comments section, and hopefully we'll get to the bottom of it. Unfortunately, I can't say that we've built a working 1581. We've built a 1581 and it does work sometimes. I think we're going to have to revisit this sometime when we know what the problem is. So the final thing to do, even though these don't work reliably, is to fit them into cases and do everything up so that they are a nice package. Now I've screwed down the PCBs into the base, and I've screwed the drives onto the little drive sleds, and I've put 2 screws basically just at the back to hold the drive sleds onto the case. The reason for that is because it needs to lift up slightly at the front in order for the front panel to actually go in like that. Then I have heat shrunk a piece of sleeving over these pins, basically so that they just go on as a single unit, because single pins is a real pain to keep plugging in and out like that. And I've built a second one for the other drive, and that goes over to this board here, which has got some rectangular LEDs, and these are going to go nicely into the front panel. And just to test them and make sure that they are the right way round, because of course we know that they're going to be the right way round because the long leg is always positive, and positive is the middle wire. There we go, red and green. And of course we'll put a disc in, and it probably won't work because that is sod's law. Yep, it didn't want to know. Now this is the modded Amiga drive. It has been recapped. It has worked in the past. There's no reason it shouldn't keep working now, but obviously at the moment it is giving us drive not ready, as you can see. So what I'm going to do, the DIY Chris board, the green one, has got a little PCB which is snapped out from here, and that screws into the front of the case, and the LEDs go into that and stick out the front. So having demonstrated that they work, I'm going to solder those up, solder this wire into here and connect that up. Okay, now green one goes in the bottom, red one goes in the top. Double check the anode is positive, and that is the long wire, and that is correct, and that is correct. So that goes into there. And we can just grab a screw. These are, I think, 6mm. They work for all kinds of cases, C64s, Amigas. So, screw that in. Now, I haven't yet soldered these, so we can actually adjust the height. So we want those kind of level. And now we can solder them. So what I'm going to do is cut these side off and then go to the other side. So now we can fit that into the slot and put the lid on. And there we go. It's not, it's mucky underneath because I haven't cleaned it up. And there are some printing errors on it, but that's what it's going to look like. And we can switch it on. How about that? If I ever get it working, I will go to Badgeman and get some front panel badges for that. So that's the grey one. I will just do the white one and then we'll be done. I should also mention that I took the big capacitor out from the internal power supply on this one because otherwise the sled would not fit properly and it would not basically be level or flat. So it would need a redesigned sled to work with the internal power supply, but I'm using the CD32 power supply anyway, so that does not matter. Okay. This is all together. I've not screwed the top down, so you can see what's inside. Basically, I've hot glued the LEDs into the front panel because I don't have a little board to screw down, and that's just wired into there. This is the PC drive with a little adapter board. The main PCB is courtesy of PCBWay. That's these. And once again, thanks to PCBWay for providing those. We can power it up and maybe it will work, maybe it won't. We tried this one and it didn't. Let's try this one. Maybe it will. It's kind of a good sign-ish, but it's crashed. So let's try again. You can hear the drive gets accessed. And that worked. There we go. And you can see that was a perfect directory listing. So, conclusions. First of all, thanks to PCBWay for providing the boards. The boards are really excellent. They are a very good service. There is nothing wrong with these boards. But this kit as a concept kind of does not work. So, well, it works sometimes, but it doesn't work other times. And there's no rhyme or reason because the exact same hardware will work one day and not work another day. So, why? I don't know. Do you know? If you do, please comment down below, and maybe we'll be able to get this to work. As it stands, honestly, I cannot recommend that you build one of these kits. And it doesn't matter whether it's the enhanced board from PCBWay, or whether you get one of the other boards from, say, DIY Chris, because they are exactly the same. They sorta do not work. I say sorta because they sorta do and they sorta don't. Now, another YouTuber, Lee from Captain Commodore, has put a Gotek in one of these. This is a device that's used typically on an Amiga or an Atari ST, and it emulates a floppy drive for those machines. Now, these machines take Amiga floppy drives. So Lee has been able to adapt the Gotek and put a Gotek in here and gets it to work reliably 100% of the time. I haven't done that in this video, but I'm quite happy to do that in another video and prove that it actually does work. If you know what the problem is, please tell me in the comments below. I've used Amiga drives and I've used PC drives with the adapter board. And again, the adapter board came from PCBWay. The drives are fine. They work in the machines that they came from. All the chips are fine. They work in the machines that I pulled them out of. And the CIAs in this came out of my Amiga 500, which now needs 2 CIA chips. The 6502s I've got for my IEEE disk drives, and they work fine. I can test them in a VIC-20, they still work fine. You can even put in a CIA from a Commodore 64, a 6526. Now, I think if you do that, it won't work with the fast serial on a 128. We never got as far as testing it with a 128. We've tested it with the +4, and the reason for doing the +4 is because we have the F3 key that does an automatic directory, and it uses the old PET style disk commands, which makes life a lot easier for testing. But this should support the fast serial bus. Now, I think that requires the timing that is on the 8520 CIA, not the time of day clock that is on the 6526. So I think if we used a 6526, it wouldn't work in fast serial mode. I haven't tried it, I may be wrong, but I think that is as far as we can go with this video. So thank you for watching if you've got this far. Please like and subscribe and do all the usual YouTubey stuff. It helps the algorithm, it helps me get views, it helps me get subscribers, because it encourages me if nothing else. Anyhow, please check out my Patreon if you want to support the channel in that way. And thank you to my existing patrons. Their names are scrolling up the screen. And I will see you next time. See ya. Bye.